So we have completed expansions of solid and expansions of liquids. But for expansions of liquids, I want to tell you something like this. Look at board. Let's say there is a vessel. There is a vessel. Right. So let's say there is a small tube like this. And let's say this is the measuring cylinder. Listen to me carefully. Let's say a liquid is filled up to this level. Let's say this height is h1, and let's say cross section area is a1 square meter. So what is the height of the liquid in the vessel? h1 meters. The cross section area of the vessel is a1. Somebody unmute the mic and tell me the volume of the liquid in the vessel. Somebody. What is the
A1 into
volume of the
H1.
liquid in the vessel?
A1 into H1.
A1 into H1. Let's say, let's say we provide heat energy. We provide heat energy. Then what will happen? If we consider that vessel is not expanded, what is the assumption there? Vessel is not expanded. Only the liquid is expanded. If the liquid is expanded, what can you observe? If liquid is expanded, what's the thing that you can observe? Somebody unmute the mic and tell me. Hello?
A certain volume of the liquid will be displaced.
Certain volume of the liquid will be displaced. So this is the displaced liquid. This is the displaced liquid. So let me take the initial temperature as theta 1 degree Celsius. This temperature as temperature of both theta 2 degree Celsius. Right. So if we consider that vessel is not expanded, only the liquid is expanded, and we apply the equation v theta equals v naught into 1 plus gamma theta equation only to the liquid. What are the assumptions? We assume that vessel is not expanded, only the liquid is expanded. Then if we apply this equation only to the liquid, right, only to the liquid, if we calculate the value of this gamma, then this gamma is said to be apparent value of gamma. It's called apparent value of gamma. So therefore we say this is gamma AP. Okay. Then this gamma is said to be apparent coefficient. Earlier gamma, the gamma value that we used in 2006 question was said to be real coefficient. This is apparent coefficient. So please write your next subheading, the apparent coefficient of volume expansivity of a liquid. Please write the next subheading, the apparent coefficient of volume coefficient, the apparent coefficient of volume expansion of a liquid. Okay, dear. What is the subheading here? Somebody unmute the mic and read the subheading.
The, the apparent coefficient of volume expansion of a liquid.
Under that, please write, let us consider the following arrangement of a liquid and a vessel. Let us consider the following arrangement of a liquid and a vessel. Let us consider following arrangement of a liquid and a vessel. Please draw everything that I have written on the board. So you just write the subheading as the apparent coefficient of volume expansion of a liquid. After that, draw and write down everything that we have written. Only these are the things that we have discussed today. We didn't do anything more than this. We have written a subheading, and only these things are the things that we have written today. We didn't do anything more than them. Today we didn't give any note, only the heading is given. We have given a heading, and I'll type and send you the heading. So check the Zoom chat. I have sent the heading to the Zoom chat. The apparent coefficient of volume expansion of a liquid. You just write down the heading and draw all the things that are written on the board. Okay, did you draw the figure? Who wants more time to draw the figure? Who wants more time to draw the figure? Right, please write. Please write. If the expansion of the liquid is neglected, if the expansion of the vessel is neglected and if the expansion of the liquid is neglected and only the expansion of the
Excuse me, sir.
yes dear,
Sir, can you repeat again, sir?
yeah, I'll repeat. Listen, if the expansion of the liquid is, if the expansion of the vessel is neglected and if the expansion of the vessel is neglected and only the expansion of the liquid is considered, only the expansion of the liquid is considered, comma, that calculated value of the constant gamma, that value of the that calculated value of the constant gamma, that calculated value of the constant gamma, that calculated value of the constant gamma is said to be the apparent coefficient of volume expansivity. Apparent coefficient of volume expansivity of the liquid. Apparent coefficient of volume expansivity of the liquid. Got it? Can somebody unmute the mic and read that point there? Can somebody unmute the mic and read everything that we have written today? Somebody in the class? Akila, can you read? Ashen Bandar, can you read?
Sure, sir. Star point, let us consider the following arrangement of a liquid and a vessel. Then draw the figure on the board. If the expansion of liquid is neglected and only the expansion of liquid is considered, that calculated value of the constant gamma is said to be the apparent coefficient of volume expansivity of the liquid.
Thank you, dear. Who wants to listen to the note again? Anybody in the class?
So is it if the expansion of the vessel is neglected or the expansion of the liquid is neglected?
Expansion of the vessel is neglected. Expansion of the vessel is neglected. We consider only the expansion of the liquid.
Okay, sir.
Okay. Pulastit, please read the note again if you have written it. Others can check it again.
Sir, do you want me to read the last point?
No, dear, everything from the starting.
So I have some missing parts of the note also.
Then I'll ask somebody to read from the beginning, then you can complete the notes, right? Atika, can you read? Asma Lafir, can you read? Asma, are you in the class? Sadrushika, can you read?
Yes, sir. Let us consider the following arrangement of a liquid and a vessel. If the expansion of the vessel neglected and expansion of the liquid considered, that calculated value of the constant gamma is said to be the apparent coefficient of value expansion of liquid.
Right. If the expansion of the vessel is neglected and only the expansion of the liquid is considered, that calculated value is said to be the apparent coefficient of volume expansion. Right. Please write example. 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 If the theta 1 temperature is, 0 degree Celsius, if the theta 1 temperature is 0 degree Celsius and theta 2 is 100 degree Celsius, theta 2 is 100 degree Celsius, comma, the displaced volume of the liquid will be, the displaced volume of the liquid will be, look at board, 0.2 cubic centimeter. 0.2 cubic centimeter. Full stop. The cross-section area of the vessel is, look at board, 4 square centimeter. Look at board and write. The cross-section area of the vessel is 4 square centimeter and the initial height of the liquid in the above vessel, and the initial height of the liquid in the above vessel is 5 centimeter. 5 centimeter. 5 centimeter. First stop. Calculate the apparent coefficient of volume expansivity of the liquid. Calculate the apparent coefficient of volume expansivity of the liquid. Okay, dear? Right. Roman number 2. If the volume expansivity of the material of the solid vessel, if the volume expansivity of the material of the solid vessel is 3 into 10 to the power minus 5 per degree Celsius. If the if the coefficient of volume expansivity of the material of the solid vessel is 3 into 10 to the power minus 5 per degree Celsius, comma, calculate the coefficient of real expansivity. Calculate the coefficient of real expansivity of the volume of the, calculate the real expansivity, calculate the real coefficient of expansivity of the volume of the liquid. Calculate the real coefficient of volume expansivity of the liquid. Calculate the real coefficient of volume expansivity of the liquid. Calculate the real coefficient of volume expansivity of the liquid. Right. Now somebody unmute the mic and read the read Roman number 1 and Roman number 2 again. Sorry, read the complete example again, somebody.
If the theta 1 temperature is 0 degrees and theta 2 is 100 degrees, the displaced volume of the liquid will be 0.2 centimeter cube. The cross-section area of the vessel is 4 centimeters squared. The initial height of the vessel is 5 centimeter. Calculate the apparent volume expansivity of the liquid. If the volume expansivity of the material of the solid vessel is 3 into 10 to the power minus 5 degrees Celsius minus 1, calculate the real coefficient volume expansivity of the liquid.
Thank you, dear. Who wants to listen to the question again? Anybody in the class? Right. Sadirshika, can you read one more time, dear?
Okay, sir. If the theta 1 temperature is 0 degrees and theta 2 is 100 degrees, the displaced volume of liquid will be 0.2 centimeter cube. The cross-section area of the vessel is 4 centimeters squared. The initial height of the vessel is 5 centimeter. Calculate the apparent volume expansivity of the liquid. If the volume expansivity of the material of the solid vessel is 3 into 10 to the power minus 5 degrees Celsius minus 1, calculate the real coefficient volume expansivity of the liquid.
Right. And somebody please take a photo of the everything that we have written and send to the WhatsApp groups, dear. Take a photo of everything that we have written today. Send and please send to our WhatsApp groups. It will be a help, a big help for all the students in the class. Right. Look at board, dear. Don't write anything, just look at board. So, what is the, how do you find, don't write, how do you find the initial volume? How do you find the initial volume? Initial volume of the liquid. Initial volume of the liquid at 0 degree Celsius temperature. How do we find this? Don't write. Don't write. How do we find this? The initial volume of the liquid at 0 degree Celsius temperature. How do we find it here? Somebody? Lamai? Darwane? දැන් මෙතන මැට්ස් ක්ලියර් කරනුන් ඉන්නවා නේද?
The cross sectional area into the initial height.
Very good, Pulasti, very good. It's a cylinder. Therefore, the liquid in the vessel is a cylindrical column. Therefore, volume of the liquid is equal to the volume of a cylinder of height h1. So that is cross section area into height. So that is a1 into h1. Correct or wrong? Who would like to explain that again? Anybody in the class? Okay, right? So this is a1 into h1. A1 cross section area of the vessel is given as 4 square centimeter. 4 square centimeter. H1 is given as 5 centimeter. 5 centimeter. So 4 times 5 is 20 square centimeter into centimeter cubic centimeter. So this is the amount of liquid in the vessel at the beginning at 0 degree Celsius temperature. Write it there. Okay, dear. Right. Then the star point and right. The star point and right. If it is assumed that star point and right below this star point and right, if it is assumed that the vessel is not expanded, if it is assumed that the vessel is not expanded, the vessel is not expanded, comma, the final volume of the liquid, if it is assumed that the vessel is not expanded, the final volume of the liquid, comma, should be equal to the final volume of the liquid should be equal to the summation of, initial volume of the liquid, and the displaced volume of the liquid. Summation of the initial volume of the liquid and the displaced volume of the liquid. Okay, right. Who would like if I repeat it? Anybody in the class? Right. So then look at board. Then what should be the final volume of the liquid? Final volume of the liquid at 100 degrees Celsius temperature. Initial volume is 20. The displaced volume of the liquid is 0.2. Therefore, the total volume will be 20 plus 0.2. That is 20.2 cubic centimeter. Complete it there. I have said that if it is assumed that, the last point, I have said that if it is assumed that the vessel is not expanded, the final volume of the liquid should be equal to the summation of initial volume of the liquid and displaced volume of the liquid. Okay, dear? Right, now look at board there. Initial volume of the liquid is 20. So that's this volume. So when the temperature increases, liquid tries to rise up, but it cannot rise up. It will flow through this tube and collected in the measuring cylinder. The volume of the liquid collected in the measuring cylinder is 0.2. So if we do not think, if the vessel is not expanded, volume of the liquid in the vessel is still 20. So expanded volume of the liquid 0.2. Therefore, the total volume of the liquid in the vessel is 20 plus 0.2. Got it? Right.
Yes, sir.
Okay, then what are the other things that can be done? Right. So leave a line. Are you okay with these two statements here? Anybody wants to explain these two statements again? Anybody in the class? Who wants to explain these statements again? Right. Initial volume of the liquid is the volume of this part. Volume of this part is cross-section area into height, that is 20. Final volume of the liquid is, so if the vessel is not expanded, this will be 5 centimeter, this will be 4 square centimeter. So this volume is again 20. That is equal to the initial volume of the liquid. They are not changed because vessel is not expanded. That's how we think. Then total volume will be initial volume plus expanded volume, that is 20 plus 0.2, 20.2 cubic centimeter. Right, please write. Let us apply the following equation to the liquid by neglecting the expansion of the vessel. Let us apply the following equation to the liquid, comma, by neglecting the expansion of the vessel. By neglecting the expansion of the vessel. Okay. Right. Look at board here. Let us apply the following equation to the liquid by neglecting the expansion of the vessel. Look at board. The equation is V theta equals V naught into 1 plus gamma theta. Final volume is 20.2. Initial volume at 0 degree Celsius is 20. Volume at 0 degree Celsius 20. 1 plus, now this is said to be gamma apparent. Theta is now 100 degree Celsius. Let's take 20 to this side. So 20.2 divided by 20. What do you think about the units there? 20.2 cubic centimeter. 20 is also cubic centimeter. So therefore units cancelled out. Equals 1 plus gamma AP. What is the unit of Celsius? 100 here. That is Celsius. So I have written the units. Then you will identify that cubic centimeter will be cancelled out. Only Celsius will be there as the final unit. So can you do the rest and find gamma AP here? Give a try. How do we simplify this, dear? How do we simplify this? Hmm? Let me give a try. Cubic centimeter cancelled out. 20 divided by 20 is 1. 2 divided by 20 is 0. Again, 20 divided by 20 is 1. Equals 1 plus gamma AP times 100. The unit of 100 is Celsius. So let me take this plus 1 to this side as minus 1. 1.01 plus 1 come to this side as minus 1 equal gamma AP times 100 degrees Celsius. 1.01 minus 1 is 0 0.1 minus 1 0. 0.01 equal gamma AP times 100 degrees Celsius. If you take 100 degrees Celsius this side, 0.1 divided by 100 degrees Celsius equals gamma AP. So finally we get, it's not written. Finally we get gamma AP equals 0 divided by 100, 0. 1 divided by 100, 0. 10 divided by 100, 0. 100 divided by 100 is 1. Divided by Celsius comes up as per degree Celsius. So what is the unit of gamma AP then? Per degree Celsius. Who got this answer? Who got this answer, dear? Somebody had obtained answer as 1. That is impossible. Please check the calculations there. Are you okay with the calculations? Okay, please check the calculations and correct it. And if you have any doubt or if you want me to explain the calculations again, let me ask. I can explain again, right? I'm not tired.
Excuse me, sir.
Wait. This should be 0.01. That another 0 should be there. 0. You see this? 0.01 divided by 100. So then if you divide by 0 divided by 100, 0. 0 divided by 100, 0. 1, yes. That's a small mistake. Check. Please check again there. After this, I'll write the simplification here. After this one. So here we have written 0.01 equals gamma AP times 100 degrees Celsius. If you take 100 degrees Celsius this side, 0.01 divided by 100 degrees Celsius is gamma AP. So therefore, gamma AP equals 0 divided by 100, 0. 1 divided by 100, 0. So 0 divided by 100, 0. 1 divided by 100, 0. 10 divided by 100, 0. 100 divided by 100 is 1. Denominator Celsius comes up as per degree Celsius. So how many zeros should be there? 0.12301. Please correct it here. Please correct the mistake here. Please correct it. Sorry. Who wants more time to write the things, dear? Who wants more time to write the things? Right, let's continue, dear. Let's continue. Please write. Roman number 2, it means I'm going to find the real coefficient of volume expansion. In the second case, we believe that not only the liquid but the vessel is also expanded. Earlier we thought that vessel is not expanded. Now we are going to think that vessel is also expanded. Roman number 2 and write, please write two statements. Initial volume of the section of the vessel. Initial volume of statement, Roman number 2 first statement. The initial volume of the section of the vessel. Initial volume of the section of the vessel which contains the liquid. Which containing the liquid, or which contains the liquid. Initial volume of the vessel which contains initial volume of the section of the vessel which contains the liquid, within brackets V1 equals A1 into H1. Within brackets V1 equals A1 into H1. Is it clear for you or not? Who wants me to repeat that note? Anybody in the class?
Sir, can you repeat, sir?
Yeah, I'll repeat that statement. The initial volume of, let me repeat, the initial volume of the section of the vessel which contains the liquid. The initial volume of the section of the vessel which contains the liquid equals section of the vessel which contains liquid is this here. We do not worry about the upper section. We should not worry about the upper section. So section of the vessel which contains the liquid is, height is h1, the cross section area is a1. Am I right there? This is the section of the vessel which contains the liquid. Which contains the liquid. Okay. Therefore, volume of the initial volume of the section of the vessel which contains the liquid is A1 into H1 because it's a cylinder. Okay or not? Who would like if I explain it again? Anybody in the class who wants me to explain it? Anybody? It's so simple. What is the height, Fatima? What is the height of the vessel which contains the liquid? What is the height of the liquid column in the vessel? Hello? Fatima, you asked me to explain, so you have to answer my questions. What is the height of the liquid column in the vessel? Okay, she doesn't answer. Right, so A1 is cross section area 5 square centimeter. H1 is, sorry, A1 is 4. A1 is 4 square centimeter. H1 is 5 centimeter. 4 times 5 is 20. Square centimeter into square centimeter is cubic centimeter. So this is the volume of the section which contains the liquid, and it is equal to the initial volume of the liquid at 0 degree Celsius temperature. So section of the vessel which contains the liquid is equal to the volume of the liquid. So we got the same answer even from this. So please write it there. Please write it there. Next statement. The final volume of the section of the vessel. The final volume of the section of the vessel the final section of the vessel which contains the liquid. Final section of the vessel which contains the liquid of the vessel. Final section, a final volume of the section of the vessel. Final volume of the section of the vessel which contains the liquid. Final volume of the section of the vessel which contains the liquid. Which contains the liquid equals V2 cubic centimeter. So what are the two statements that we have written here? Somebody please unmute the mic and read the two statements that we have written as V1, V2.
Initial volume of the section of the vessel which contains the liquid V1 equals A1 into H1. So we should read that also, sir.
No dear, read only the two statements dear from the beginning. Please restart dear.
Okay, sir. Initial volume of the section of the vessel which contains the liquid V1. The final volume of the section of vessel which contains the liquid V2.
Okay. Thank you dear. Anybody wants to listen to it again? Anybody wants to listen to the two statements again? Sadarshika, can you read it? Read them again, dear.
Okay, sir. Initial volume of the section of the vessel which contains the liquid V1. The final volume of the section of the vessel which contains the liquid V2.
Okay. Leave a line and write, let us apply the following equation only to the solid vessel, only to the section of the vessel. Let us apply the following equation to the section of the solid vessel. Let us apply the following equation to the section of the vessel which contains the liquid. Let us apply the following equation only to the section of the solid vessel which contains the liquid. Which contains the liquid. Let us apply the following equation only to the section of the vessel which contains the liquid. Which contains the liquid. Right. So I'm going to apply the equation. V theta equals V naught into 1 plus gamma theta. What's the equation that I'm going to apply here? V theta equals V naught into 1 plus gamma theta. V theta is the volume of the vessel, volume of the section of the vessel, this section, volume of the section of the vessel at theta degree Celsius temperature. V naught is the volume of the section of the vessel at 0 degree Celsius temperature. Gamma is a constant which is known as volume, the coefficient of volume expansivity of a solid. Theta is the final temperature of the liquid. So final temperature of the liquid is actually 100 degree. Value of gamma is given as 3 into 10 to the power minus 5. So V theta is taken as V2, V naught is taken as V1 plus gamma theta. Actually value of gamma is given as 3 into 10 to the power minus 5, theta is 100. So V2 equals V1. The initial volume of the section of the vessel which contains the liquid is 20 cubic centimeter. 20 cubic centimeter equals 1 plus 3 into 10 to the power minus 5 into 100. Because of these two zeros, 10 to the power minus 5 becomes 10 to the power minus 3. 10 to the power minus 3. Got it? So then this is 20 cubic centimeter into 1 plus 10 to the power minus 3 means 3 decimal points, 0 0.123. 1, 2, 3, 10 to the power minus 3, 3 decimal places. So that is 20 into 1.003 cubic centimeter. Let me multiply. 20 times 3, sorry, let me write the 0 here. I'll write this 0 here, then I'll multiply by 2. 2 times 3 is 6, 2 times 0, 0, 2 times 0, 0, 2 times 1 is 2. How many decimal points should we remove here? How many decimal points there? 1, 2, 3. So let's remove 3 decimal points. 1, 2, 3. So final decimal point should be here. So 20.060 cubic centimeter. Completed there. So this is the volume of this section. 20.060 is the volume of this section of the vessel. Got it? If you have doubts, you can unmute the mic and talk to me, right? Please tell me once you have written everything. Who wants more time to write? Okay, so please write. Now look at board there. Somebody unmute the mic and tell me the volume of this section of the vessel. Volume of this section of the vessel. Somebody please tell me. You know the rule, right? You know the law. If you are silent, I will also be silent.
20.06 cubic centimeter.
That is V2, that is 20.06
cubic centimeter.
20.06. We should not worry about this 0 cubic centimeter. Therefore, what is the volume of this liquid there? Huh?
20.0.
What should be the volume of this liquid?
20.06 cubic.
20.06 cubic centimeter. Volume of this liquid, it's already 0.2 cubic centimeter, it is given. Now tell me the final volume of the liquid at 100 degrees Celsius. What is the final volume of the liquid at 100 degrees Celsius temperature? Somebody?
V2 plus 0.2.
20.06 plus 0.2. Okay or not? Lamai?
Okay,
If
sir.
you are silent, I will also be silent. So what is the final volume of the liquid then?
20.06 plus 0.2.
Very good. So volume of this section is 20.06. Volume of the displaced liquid 0.2. Therefore, final volume of the liquid is 20.06 plus 0.2. So that is 20.26 cubic centimeter. What is the initial volume, dear? What is the initial volume of the liquid? That is initial volume of the section of the vessel. V1, A1 into H1. So that is 20 cubic centimeter. So therefore, what should be the volume of the liquid? What should be the volume of the liquid at the beginning there? Somebody?
20 cubic centimeter.
20 cubic centimeter. So now volume of the liquid is increased from 20 cubic centimeter to 20.26 cubic centimeter. So that is the real expansion of the liquid. Now draw this figure. Draw this figure and write down everything that I have written on the board. Draw this figure. These things are essential here. Do not worry about the time duration that you learn. Worry about the things that you have understood. That's the point. Whatever the things that you have written, if you have not understood anything, that is completely useless. So do not worry about the time duration, and we are highly leading in the syllabus. So please draw this figure and write these statements, these two statements. Start. Don't be lazy. Write them all. Draw everything. Right. Who wants more time to write the things? Any doubts? Who wants more time to write, or who wants who does have any who wants any further explanations, dear? Anybody? Right. So I will not erase it. I don't erase the things. I don't erase the things that are written on the board. So please write. Let us apply the following equation only to the liquid. Let us apply the following equation only to the liquid. Let us apply the following equation only to the liquid. Let us apply the following equation only to the liquid. Only to the liquid. Look at board. I apply this equation only to the liquid. V theta equals V naught into 1 plus gamma theta. Right? I apply this equation only to the liquid. Only to the liquid. Right. Look at board. V theta is the volume of the liquid at theta degree Celsius temperature. V naught is the volume of the liquid at 0 degree Celsius temperature. 1 is 1. Gamma is the volume coefficient. Theta is the final temperature of the liquid. So here we use the real volumes. We have considered, we have calculated even the expansion of the vessel. So the real volume of the liquid at 100 degrees Celsius is the real volume of the vessel plus real volume of the displaced liquid. So as we are using real volumes, as we have not neglected anything, the things are real. Therefore, gamma is said to be the real. B theta is 20.26. B naught is 20. 1 plus this gamma is real. The final temperature is 100. Got it? Can you do the rest and find gamma real here? You were right. Who has found the gamma real? Anybody in the class who has found the gamma real? Let's check. Let's check your answers. So let me take 20 to this side. 20.26 divided by 20 equals 1 plus gamma real times 100. So I'm going to divide this 20.26 by 20. 20 divided by 20 is 1. 12 divided by 20 is 0. 26 divided by 20 is 1. 6 remaining. 60 divided by 20 is 3. Equals 1 plus gamma real times 100. Take this one to this side. 1.013 minus 1 equals gamma real into 100. 1 point something minus 1. 1 minus 1 is 0. 0.013 equals gamma real into 100. I think you are able to see the edge of the board. Is it okay? Yeah, you are able to see the edge of the board, right? Okay. Now I'll take this 100 to the other side. So I should divide this 0.013 by 100. So then let me erase this part now. Let me erase this part now. Finally, 0.013 should be divided by 100. Then we will get gamma real. So therefore, gamma real equals 0 divided by 100 is 0. 0 divided by 100 is 0. 1 divided by 100 is 0. 3 divided by 100 is 0. Am I right there? So if you divide this, actually two zeros will be added because of the 100. After that, you will get 0.13. Unit is per degree Celsius. Who got this answer? Anybody in the class? Right. I'm going to show you something. Look at board there. I want to show you something. Somebody unmute the mic and tell me the value of gamma apparent here. Somebody in the class. What is the value of gamma apparent? Anybody?
So it's 0.0001, sir.
0. How many zeros dear?
3 zeros, sir.
1, 2, 3 zeros, 1. Am I right?
1. Yes, sir.
Then what is the gamma solid? Gamma solid vessel. Lamai.
3
Volume
into 10 to the power
coefficient of
minus
the solid
5.
vessel is given here. Somebody please tell me.
3 into 10 to the power minus 5.
3 into 10 to the power minus 5 per degree Celsius. So here how many zeros? 1, 2, 3, 4. This can be written as okay. What is gamma real? Here gamma real. What is gamma real? 3 zeros, 1, 3. Am I right? 1, 2, 3, 1, 3 per degree Celsius. How can we write these values there? I can write it like this. 1, 2, 3, 4. I can write 5 by adding a 0 here. Am I right? So this can be written as 10 into 10 to the power minus 5 per degree Celsius. Can you understand that, Masdi? If you have a doubt, please ask. Clear or not? Minus 5. 1, 2, 3, 4. I have written another 0, 10, and 10 to the power minus 5. Okay? Okay or not?
Okay, sir.
Okay, sir.
Similarly, 1, 2, 3, 4, 5. Then 13 into 10 to the power minus 5. Now all the numbers you see minus 5, 10 to the power minus 5, 10 to the power minus 5. Okay. So what is the relationship between gamma real and gamma apparent here? You see, you will get, if you add gamma apparent to the gamma solid, you will get it. Am I right? This is 13 into 10 to the power minus 5. This is 10 into 10 to the power minus 5. Am I right? This is 3 into 10 to the power minus 5. Correct or wrong there? Gamma real equal gamma AP plus gamma solid. So this is the relationship. But we have proved that last week gamma equals 3 times alpha. What is alpha dear? For a solid, this is a correct relationship. So what is alpha dear? The coefficient of linear expansivity. The coefficient of linear expansivity. So then volume expansive equal 3 times gamma alpha. So sometimes this relationship will be given in the examination, or sometimes they will give you values to prove the equation like this. So please write this as a special note. Do not forget this like that.